I know some of you guys in the room, but if you're not familiar with me, my name is Otis Alexander. I work for the Miner Corporation. I've been there since 2014, and I broadly focus on cyber physical, ICS cybersecurity. My official title is a principal OT cybersecurity engineer now. And in public, I'm best known for my work to promote and develop Attack for ICS, which is a knowledge base of adversary behavior against industrial control systems. I'm also well known for my work to push attack evals to ICS. So we did our first round of attack evals last year, which is looking at how products are able to detect TTP within the knowledge base. So today I'll kind of be giving you a little bit of updates about Attack for ICS, but I'll also be talking about some lessons learned, some important things to consider when you're using it, especially in the use case of product testing. Next slide. Did that work? No, she told me to do that. Oh, there it goes. That was magic. Sweet. All right, looks like they screwed up all my slides by putting them in this thing, but that's fine. Okay, so just as background for people who aren't familiar with Attack for ICS, it was released in January of 2020, right before all the craziness ensued in the world. We have been working on it for many years before that, though, so that's just a public release. To get specific, we're filling a gap that wasn't in the attack ecosphere. So we talk about enterprise, we talk about mobile, we've got into cloud, but ICS specifically at the lower levels was a gap that we were trying to fill. So we're specifically talking about industrial control systems and critical infrastructure and verticals such as, electric power, water, transportation, all those nice critical infrastructure verticals that rely on industrial control systems. And we're really trying to highlight the attacker behavior, what they're doing specifically, and the impacts that they cause within systems. Next slide. Okay, so usually what we try to do is reference the Purdue reference architecture to talk about where we fit into the whole picture. So if you build one slide, next slide. Let's see if this comes through. So anyways, we on the right-hand side, you can see a triangle coming down. That is enterprise attack and kind of where it fits into the reference architecture. So basically, we know that enterprise attack with its Windows systems, Linux systems is going to fit into enterprise, operational management, supervisory control, and it's going to trickle down to area control a little bit. But at some point in time, we're not going to be able to talk about the TTP that adversaries are using at the low levels. So that's really where Attack for ICS comes into play. It's really talking about the applications, protocols, and especially hardware that are affected by attackers in these systems. Next slide. I think you're gonna have to hit it twice. So there's the building. Next slide. Next slide. Okay. So the way we like to think about it is they should be leveraged together. When we look at an incident report for a major incident, we break it down with enterprise attack first. We go as far as we can. Once there's a gap, those are the TTP that we concentrate on leveraging in Attack for ICS. And we've mentioned this in our philosophy paper for Attack for ICS. We've also, gone on record in presentations, and we really harp on the need to use them together. But our friends at Mandiant also, saw the need for using it together, and they wanted to write a joint blog post with us, and they used the word gestalt. I think it's a great word. When you're talking about systems of systems, gestalt kind of fits in. So it's a structure that, when considered as a whole, has qualities that are more than the total of all its parts. So using Attack for ICS by itself doesn't really make a lot of sense. You have to put it together to actually tell the full story. But we still have a lot of questions to answer with this knowledge base. So with both of them. So where should techniques live? Should they be in enterprise? Should they be in ICS? Are enterprise techniques the same as OT techniques? Enterprise has a different definition than OT in most cases. And then how do we better leverage the two knowledge bases together? So this is going to come down to more people using it, more people figuring out what works for them and relaying that information to us. But there's a lot of bigwigs in this area that have their opinions, and OT has its own mission. It's different than enterprise. We don't really care what banking systems are getting affected with. We really care about OT. The problem is with incident reports, it's very hard to know where OT begins and enterprise ends. That's not like really stated clearly in a lot of the reports. So there's a little ambiguity there. But next slide. We're moving towards using or making it easier for the end user to use these two together. So in April, we moved the ICS knowledge base to the main attack.mitre.org site from the collaborate.mitre.org site, where we had a wiki for a very long time. It allowed us to rapidly develop and mature, but having it here makes the most sense because now people can use it all together in one space. So if you go to the next slide. So it's hard to see here, but just some updates on how we merged everything together. So the matrices are separate. The individual techniques, tactics, and the like are separate. They live on their own. They're associated to a technology domain. But where it makes sense, where you have software or groups that have targeted ICS and hit enterprise and the industrial control systems at the same time, we merged all the techniques together. So for software, for instance, you have Indestroyer up here, you have enterprise techniques right next to ICS techniques. If you go to groups and you look at the particular group associated with that, you'll see the techniques merged together also. In data sources, what are the building blocks for detections? We have toggle buttons now where you can either look at ICS data sources or enterprise data sources or both at the same time. So we've done a lot of work, ground work to help people be able to use the knowledge bases better together. And that's very important, especially when you're doing security testing of products. You don't want to just focus on one part of it. You want to focus on the full life cycle of the adversary. Next slide. So let's talk about this testing of security products a little bit more in depth. I wanted to give you guys an update of what we're doing. There's definitely some applicability to using both knowledge bases together for testing security products, but let's move off into the attack evals realm and talk about some of the lessons learned from that. So next slide. So this is really the why behind attack evals. We've seen a lot of external entities, whether they're government or asset owners, operators, or security vendors, referencing attack, talking about their use cases for it, how they map to it, how they cover it, different things like that, which is all very great. We like these derivative works because it informs the community about how you can potentially use attack for ICS, and you get to compare the different use cases between a lot of different companies. Next slide. And then just recently, we also saw that multiple entities started reporting out an attack for ICS as well. So this is becoming a common lexicon. It allows us to see any differences in terms of reporting. So if one entity reported something in an enterprise, or they reported, this set of ICS techniques, now you can compare against another report to see if they have different intel than the other report. So that's a good use case. Plus, if an end user of these products doesn't understand, what this particular activity was, right? They can go to Attack for ICS. They can start reading the description. They can see how other adversaries have used it in the past and get better context about what this particular behavior actually means. Next. And then we've gotten all the way down to the detection platforms. So at some point in time, I'm hoping that these are used ubiquitously throughout ICS. So we have better understanding of the threat. So we have better incident sharing and the like, better detection. We start training up analysts and different things in the OT realm. So the very fact that they're mapping their alerts to attack for ICS is another good sign. But one of the things I've seen that's a little worrisome is people say we cover 100% of attack for ICS, right? It's the claim that all vendors are going to make. And who am I to tell you that you're wrong, right? One of the things that we have to be careful with those claims is this ecosystem is huge, right? How many vendors are out there? How many applications? How many protocols? How many verticals, right? So we talk about one vendor, one line for one vertical. There may be 10 different versions of firmware over the last 10 years that change how you detect a particular behavior. So, you got to be kind of careful when you say you cover 100% of it, because we specifically made it at an abstract level where it could cover multiple verticals, multiple vendors, multiple protocols, right? So there's a lot underneath that you have to do as a vendor to be able to cover everything. And next slide. What's the best way of checking the vendors on these claims? It's to do a test. So that's what we did last year. We, through MITRE Ingenuity, we moved into the technology domain of ICS. It was the first time we moved to a new technology domain from enterprise, and we decided to cover the Trident attack. And you guys are probably familiar with that attack. Saudi Arabia, 2017, petrochemical company, yada, yada, yada. So our main goal here was to think about how ICS passive detection products detect TTP associated with this particular malware. So we weren't running this malware directly. We used the TTP and we applied it to a whole other system, Allen Bradley systems instead of Schneider. And our whole goal in doing this is to empower the end user to understand what products are out there for them to use, because we really want them to have these products in their environments. And then we want to provide transparency so they understand what the true capabilities of these products are, what they actually can do, and not just claims, not just marketing, not just what your friend told you. And then we want to enhance the product. So, there's vendors that had to make config changes during this activity to be able to detect something. I'm sure in the background, they were like, oh crap, why aren't we, detecting this, or why is this at such a low level? That's a prime opportunity for them to make their product better. So this is really about the public good and really understanding what's out there in terms of capabilities. Next slide. So why Trident? Why do we pick this? You hear about ransomware. There's other things that are interesting out there. Trident happened in 2017. You're working in the past. Why do we pick this? So the prime reason why I chose Trident is the configuration changes, because I think it's huge. Change management in these systems is a big thing. And it's a big thing in previous attacks as well. So change management is behind Stuxnet, it's behind Trident, it's arguably behind Marucci Shire. It's behind Indestroyer as well to a degree with the update to the serial Ethernet gateway with the DAT firmware. So configuration changes are a prime part of some of the most dangerous attacks out there. So what we really wanted to do is focus on those things, those configuration changes. And it's so insidious because they're similar to what engineers do. Once you make that configuration change, it's on a low-level device. It doesn't have to be executed right now. It could be executed off in the future. It could act weirdly in certain conditions, but the thing is, there's no immediate impact in a lot of these cases unless you mess up. So you have all the time in the world to do what you want later on. So I kind of didn't want to focus on something that was more telemetry-based, where you're, spoofing sensor signals or sending commands down to open breakers or something. It's a little too simple. for us. We wanted to focus on some of these more sophisticated attacks that get down to the lower level. So there's something to worry about here. If you go to the next slide. Okay. We're doing an emulation full of standard actions that aren't malicious on their own. If you look at attack for ICS, it's things that engineers probably do in every system, probably every day, you know? So you really have to ask yourself, why is this bad? How are you going to highlight this as bad to an analyst, to somebody who can do something in that system about it? So some of the things that you may have to consider is, you know, is it going to negatively impact the control system? From an analyst perspective, you may or may not know that. Should it have been performed at this particular period of time? Or are there any directly relatable malicious TTP associated with this particular action? So I mentioned this in a previous talk when I was kind of talking about attack evals, those 3 points. But what I didn't bring up is we also could look at whether it deviates from a normal. You know, this is not a novel idea. This is my grad research and baselining systems, finding norms, and what was the direction of the community in this, you know, in this regard. But it's very important with these things, because you're going to get a ton of telemetry and alerts and different things from these platforms that you don't know how to deal with. And you're going to be asking yourself, maybe this is normal or maybe it's not normal. So when we did attack evals, we did it on a small system. And this is how enterprise does it too, is so that you can be able to really understand. Can you go one slide over? You're in the right slide, actually. Thank you. We did it in a small environment so that we can understand what was happening. If it was too big, it would be too hard to deal with 5 vendors and the like. So, I mean, at max, we have 7 computers. We have 2 PLCs, 1 remote IO, and then we have hardware in the loop simulation for a burner management system that, you know, may be found at a petrochemical company. So that's what the intel told us. That's what we did. There's a firewall to allow for remote access or to move patches in and the like, but it's a small system. We got a ton of alerts, a ton of telemetry. You can look at the site for attack evals and see all the screenshots and all the records there. Next slide. What happens when this scales? What happens when we're in a really big system? And one of the things I see with analysts is they're thrown into a pile of data with no context about the system, no ability to baseline the system or find a norm, which is very important. Next slide. Next slide. So our ability to find a normal is important. Can we get the next slide, please? Thank you. So our ability to find a normal is important. And, you know, working with our sponsors and government, working with asset owners, what I've always recommended is starting at the identify function or stage for NIST. It's important, right? Because you can't defend an environment, you can't tell something's normal if you don't understand the environment. So this includes, you know, understanding policies, procedures, and processes, understanding who the personnel are who may be making these changes, understanding communication and data flows, software applications, and the hardware assets that are in the environment. And you can look at this from 2 different ways. You can look at it from a document-based artifacts perspective, which are always going to be out of date, which always may not be there, which may not be shareable. Or you can look at a data-driven perspective. If you already have that data coming in, what can you derive from certain things, or what systems can you get access to give you a little bit more information? Next slide. So what I propose, especially for this use case, we're talking about engineering actions, we're talking about understanding what's normal, is that you focus on these 2. From a data-driven perspective, you may have to look at how certain policies are implemented. You may have to work with an engineer to get workflow demonstrations to understand how they accomplish something. You may have to get network captures. And a big one that I kind of want to harp on is issue trackers. because if the organization is progressive enough, they have a change management system in place, they're documenting these things, then that may be something that you can leverage. So next slide. So really what I'm saying here is there's a deficiency in purple teaming. I think everybody understands purple team is, red team, blue team. That's what we said, it makes purple, right? What about white? We include white sometimes, the infrastructure team, people talking back and forth. But what else are we missing? We have the red team, purple team, we have a white team, we have our infrastructure, we have our process perfect, we have the hardware in the loop. Where the hell is the engineer? Who's actually making the changes in the system while you're running this exercise, right? How do you know that what you're looking at is not normal or abnormal? I think this is a prime thing that's missing from a lot of our exercises, and it's a big takeaway from attack evals, because anybody can say they did great on it, but if you have a whole bunch of alerts and telemetry that aren't actionable by a defender, you're just going to wear them out, and they're going to be faced with asking, is this normal or not normal? So my last slide here, next slide. This was one of my recommendations, is, working with a work order system. If you're working with an asset owner, an operator that is sophisticated, I know back in 2005, a lot of the IT shops were just moving to ITIL and, really absorbing their best practices, especially in change management and documenting everything you do with a system. If you're working with an asset owner that is actually doing this, leverage that system. The work orders tell you date, time, location, assets involved, and the IP's host names, makes, models. It also tells you a little bit about what service was conducted, what happened to that particular system. And then in certain cases, for really sophisticated asset owners, operators, they'll attach the firmware or the project or the program that they use to update the asset to that work order. Now, as an analyst, if you have that as a data source, you get a better idea of what normal is. So my real call is to understand maintenance trends to develop a norm, because the configuration change management use case has been important to a lot of attacks, and that's what we've seen from attack for ICS. So we need to figure out a better way of understanding when these things are malicious. So that's all I have. Hopefully there's some questions, or if we have time.
We can, and we will. So if anyone has any questions for Otis?
Sure. Otis, thanks for your presentation. Can you discuss a little on how you are seeing MITRE ATT&CK not being used adequately, or at least efficiently, or if you want to answer it that way, ways in which people could do a little bit better? I know we kind of dived into it.
Right. I don't have a use case that I can think of right now, but I do see it being used wrong in terms of somebody interprets a technique as being something and they really haven't dug deep enough, right? So it's like, everybody wants a short little blurb to tell you what a technique is, but you got to understand there's a description, there's procedure examples, there's a whole ton of references underneath, and you need to use that to better understand the technique. So just spend a little bit more time understanding what techniques mean.
Can I ask a follow on to
Yeah,
that?
sure.
I know attack, defend, the training modules through MITRE for attack.
Attack defender, yeah.
Yeah, is there, I know that's like an attempt to fix that. Is there plans for an ICS?
Are you talking about the training, or are you talking about defend?
The training.
Oh, yeah, I haven't talked to them about that.
Okay.
Yeah, I know the person who leads it, just
Okay.
haven't had time yet.
Sure.
So yeah, it's a good point though.
And I do have my own question.
Yeah, sure.
So the comparison, the enterprise to ICS tool that you showed, first off, super excited to hear that ICS is now on the main page.
Yeah.
I always, every time I click that link and it opens up a new tab. I'm
Yeah,
like,
it's
what's
annoying,
going
right?
on?
Yeah.
But was that created because you found users who were actually flipping between tactics, or is that kind of trying to encourage people in the future to make the comparison?
I actually tried to slow it down, to tell you the truth,
Oh, okay.
because I wanted a little bit more time to work on our wiki, and have the time to, do it in a more agile way. I'm not
Sure.
saying that this isn't agile. It's just you have a little bit more control. It was actually demanded, you know, multiple times, you know, by people. It was a huge request. The lead for attack had mentioned, I'm always hearing this, why isn't it here? So
Yeah.
it was really community demand, and what better reason to do something than the community demanded it, so.